Hey everyone, my name is Eric Jones, better known as the Turf Teacher, and what we're going to do right now is we're going to look at a snow math lab that I've created. It is some typical snow math calculations that you may come across. They're a little bit probably more on the municipal side of things. I've kind of put together some different scenarios that we could look at, and then hopefully as this week progresses I'll be able to do a little bit more snow math demonstrations. But what I wanted to do was work these 15 problems for you guys. And so let's go ahead and read number one. While snowstorms in Boone, North Carolina routinely leave up to 5 feet of snow on the ground, the first winter snowstorm deposits, on average, 18.7 inches of snow. According to the Public Works Department, the snow removal rate is directly proportional to the number of inches of fallen snow. For the town's fleet of snowplows to clear all the roads after a storm, leaving 10 inches of fresh snow on the ground, it takes roughly 25 minutes. It takes 1 hour to clear the town's roads of 24 inches of freshly fallen snow. If the rate of snow removal remains constant, how many minutes will it take to clear all the roads in the town after the first winter snowstorm, assuming it deposits 18.7 inches of snow? Express your answer to the nearest minute. And guys, what we're going to look for is we're going to look for M, or minutes to clear. Minutes to clear. And so we know that it took 25 minutes for the 10 inches. So we're going to say 10 inches over 25 minutes is equivalent to what we're trying to find it for, of 18.7 inches over M. And so what we're going to do is we're going to cross multiply these numbers. And what I'm basically getting, I'm getting 10M equals the 25 times the 18.7, which leaves me 10M equals 467.5. We're going to divide by 10 on each. And so we've got M equals 46 minutes, 0.75, or 46 minutes 3/4, or M equals 47 minutes to clear roughly an 18.7 inch snowfall. Hopefully my table's not shaking so bad that you can't see this math. And so again, guys, this is probably I'd have to go back and look at the town of Boone and see what the average snowfalls is. What I've done is I kind of created these numbers to kind of give you guys how to do it. I mean, this could be done for parking lots. This could be done for, pretty much any type of roadways or sidewalks even. And so what I need to do is break it down, and I'm going to do it later on for you guys for the typical landscape contractor that's out there doing snow removal services, and, break it down per sidewalk, per road, per parking lot. So let's go to problem number 2. We'll slide the paper up here. And it says, after each snowstorm in Greensboro, North Carolina, plows remove snow from 762 lane miles of road, which is equivalent to about 48 million square feet. The snowfall total was 34.2 inches in Greensboro last winter. I have to go back and look. We had a lot of snow last winter. But suppose every snowfall evenly blanketed all road surfaces. How many cubic feet of snow were plowed last winter in Greensboro? And so we're actually looking at cubic feet of snow, and that's how we're gonna kind of calculate that. So we know that we had 34.2 inches. So we're going to have to divide that by 12 inches, and that's going to give us 2.85 feet. Times the 48 million square feet of lane roads equals 136,800,000 cubic feet of snow was removed in the city of Greensboro last year. Now, as you can see, I done this in the spring of 2013. Guys, we've had a lot more snowfall here recently in the last couple of years here in the Triad. And so we're going to go back and we're going to do some more math calculations, and maybe, just maybe, for your quiz or for your test that's coming up, you'll have different math problems than this. So look at number 3. Now suppose that 1 cubic foot of snow weighs about 15 pounds. Based on this information and the last problem, approximately how many tons of snow were plowed in Greensboro last year? So, so we know a cubic feet weighs 15 pounds. So we did 136,800,000 cubic feet times 15 pounds equals 2,052,000,000 pounds of snow last year. Well, we're going to divide that by 2,000 pounds because there's 2,000 pounds in a ton. This is going to equal 1,026,000 tons of snow were plowed in Greensboro of last year. And again, I apologize if my table is shaking while I do this. But that is the first three problems. Now, let's move on to question number 4, ladies and gentlemen. And as you can see, best friends Bill and Josh work at Wake Forest University, go Deeks, where it snows an average of 55 days each year. We know it doesn't snow an average of 55 days each year. Again, this is a hypothetical question, and we're coming up to show you snow math. They take turns shoveling the sidewalk after each snowfall. Josh can shovel the walkway in 22 minutes, while it takes Bill only 14 minutes to shovel the same walkway. How many minutes will it take to shovel the walkway if they work together? Express your answer as a decimal to the nearest tenth. Now, this could be a problem where you do have employees that are out shoveling. And think about it, if you're shoveling sidewalks, as the day progresses, you may be at a Wells Fargo shoveling snow off the sidewalks in the morning. It's continuing to snow each day. You got to go back later that evening. Well, guys, guess what? Your crews are getting a little bit tired, so it may take them a little bit longer. And so what you can do is kind of come up with rough calculations on how long it might take to go back and do it a second or even a third time later that day. All right, so what we got here, it's a little crazy. Again, my table is shaking. I apologize. But we got Josh. We can do it in 22 minutes. We got Bill. Do it in 14 minutes. And so we're going to add these two. 1 over x. We're going to figure out what that is. And so we're going to take this to the top. We're going to have 11 over 154 plus 7 over the 154 equals the 1x. Takes that down to 18 over the 154 equals 1 over x. Bring down. Reduce that down to 9 over 77th equals 1x. And so 9x equals 77. It's going to take them roughly 8.55 minutes or 8.6 to do it together. Now, I may have went around the way to get that calculations, but what we figured out is we wanted to see how long it would take us to do it together. If they were doing it in the same amount of time, if they were both at 14 minutes, you could say they done it in 7 minutes. But, one was in 22 minutes, one was in 14 minutes. And so we broke it down that way. And to come up to do it together, working on it together, they could do it in 8.5 minutes. And guys, if you're keeping track of your individual workers out there doing it, and especially if you're on like some type of time management software, if you get there and if you can break down your minutes, how long does it take Josh to do the sidewalk at Wells Fargo number 1? Well, if it takes him the 22 minutes, but Bill goes back and does it the next time and he does it in 14 minutes and you've got the same amount of snowfall, you can kind of predict what the average person or how long it's going to take you to do these jobs. And so you can come up with better estimates next year and even kind of look at typical banks. A lot of the times, some of these properties may be very, very similar. And so you can come up with, a generic time frame on what it takes to do a lot of these snow removal sites. Now, let's look at number 5. One of the responsibilities of Mr. Jones' property management company in Winston-Salem is to clear the snow from the parking lot and walkways of Tanner's Run condominiums. Now, this is an actual problem because I am the Mr. Jones. He is trying to decide which of the programs offered by Elite Landscape Service and Nursery Snow Removal Division, as shown below, would best result or best suit his needs. Here's the option cost. All right, 225 times each time the parking lot and sidewalk is plowed. 2 payments of $3,652 for unlimited clearing after a snowfall. 3 payments of $2,561 for unlimited clearing after a snowfall, or 1 payment of $7,200 for unlimited clearing after a snowfall. Based on last year's snowfall, Mr. Jones estimates that he will need to have the plowing done about 35 times. Again, that's not going to happen. We're not going to do it 35 times, but in areas of the country, we may have that done. But if you're looking, if we have 7 or 8 snow events and we're having to go back 3 to 4 times on each property, yes, we can approach doing a property 35 times. So let's look at it from that aspect. So which option will cost him the least amount of money? Now, if you read chapter 15 in the Professional Landscape Management book, it's going to talk about the per push, the per inch, or the per season contract. So we kind of got all of that wrapped into this one problem here. And so I'm going to have A, which is the 225 times 35 is going to be $7,875. Option B, the 2 payments of $36.52 times 2 is $7,304. C is we're going to get the $2,561 3 times during the year. That's going to give me $76.83. And then we have D, which is just the $7,200. And so, which option will cost him the least amount of money? Well, will actually cost the condominium association less money. It would be better if the contractor or actually the Tanner's Run condominiums paid the $7,200. So we really need to say which option would cost them the least amount of money. And so, we'd rather get that 225 each time we showed up, right? Basing it on 35 times. Now, again, think about this. Let's say we do have 7 major snow events, and each snow event is going to dump anywhere from 10 to 12 inches. Well, guys, people want their parking. They don't want you to wait until 12 inches has fallen. What they're going to want you to do, and I'm sorry you guys didn't see that. I should have pushed that up. But what they're going to want you to do is you're probably going to be pushing it every couple hours when there's 1 to 2 inches of accumulation, maybe even more. Depends on how fast the storm is going. So it could equal up to where you may do that 35 times. That's problem number 5, ladies and gentlemen. Now let's look at problem number 6 on the Snow Math Lab. Tom shoveled snow from his driveway and the driveways of his 3 neighbors. Mike shoveled snow from 6 driveways. Tom started at 3 p.m. and finished at 6:45. Mike started at 11 a.m. and finished 30 minutes before Tom started. Each driveway in Tom's neighborhood is 100 feet long, while each driveway in Mike's neighborhood is 25 yards long. Tom and Mike both have the same size shovel, and each neighborhood has 4 inches of snow on the ground. Who shoveled at a faster rate? Now, you got a job application out there. You're trying to hire a snow shoveler for your snow crew. Who are we going to hire, Tom or Mike? Now, this gets a little bit kind of crazy. Make sure you guys can see all the white space here. I'm just going to draw a line. We're going to call this Tom. Tom does 4 drives. Does it in 3 hours, 45 minutes. And so he does his and 3 others. And so we got 3.75 or 225 minutes with that 3 hours and 45 minutes. All right, so next we're going to multiply 4 times 100 because of the Tom's neighborhood is 100 feet long. He done 4, he done his and 3 others. So he did 400 feet. He did 400 feet in 225 minutes. So he's doing 1.8 foot per minute. Or do it this way. Equals now we got to figure it for Mike. Mike did 6 drives, 3 hours and 30 minutes, or 210 minutes. He did 150 yards, or 450 feet. 6 drives at 25 yards. So we have 450 feet, divided by 210 minutes, equals 2.1428, equals 2.14 feet per minute, or 210 with 450 feet equal 0.466 by 1 foot equals 0.47 minutes per foot. So who shoveled at a faster rate? Would you want to hire Tom or would you want to hire Mike? Guys, actually, they're pretty close. You know, I'd hire them both, to be honest with you. But as you can see, we know how to get the math done. All right, look at question number 7. If Tom charges 50 cents per foot, Mike charges 30 per hour, who will make more money? Tom is 50 cents per foot. Let's see, Tom's 400 equals 200. Mike is 30 an hour times 3.5 equals 112.50 earned. Now, as you heard in my lecture, I don't like charging by the hour, right? I like charging per inch. You know, here he was charging per square foot and actually come out making a little bit more. Number 8, if Tom charges $25.50 per hour and Mark charges $1 per yard, what is the difference between the amount of money Tom makes and the amount of money Mike makes? So again, $25.50, that's Tom. Mike, $1 per yard times 150 yards equals 150. And so then we're going to minus the 95.63. That's $54.37. Again, guys, I don't like doing it by the hour. Can you see why? The math is, it's in the math. Now, look at number 9. If Tom and Mike charged by the hour and each made 150, how much did they charge per hour? So Mike still come out a little bit better on that deal. Still not what I like doing. If you're charging $40 an hour pushing snow, you're losing money. But, you know, these are probably high school kids out shoveling sidewalks, and that's what they are. Now, number 10. Now we're talking a little bit about ice melt. If you can get 5,000 square feet out of a 50-pound bag of ice melt for pre-treats, how many bags will it take to do 1 acre parking lot? So 43,560 divided by 5,000 equals 8.712, or 9 bags. Very easy to calculate that, ladies and gentlemen. Suppose you only get 2,500 square feet out of the same 50-pound bag of ice melt on icy surfaces. How many bags will it take to do the same 1 acre parking lot? Well, guys, that's simply multiplying by 2. 9 times 2 would give us 18 bags. Because remember, pre-treats we're getting 5,000 square feet. The rate's cut in half on icy surfaces, so we're going to have to double the amount of bags for that. If ice melt per 50-pound bags costs $12 a bag, how much money will it cost to do the pre-treat? Well, 9 times 12 equals $108. How much will it cost to apply the ice melt after the same parking lot develops an icy layer over it? Well, 18 times 12, 216. Guys, in materials alone, you got to figure labor in on that. Now, 14. If we were to use salt spread by a truck on the 1 acre parking lot and you apply 1 ton per acre, how many pounds per square foot would this be equivalent to? 1 ton over 43,560 square feet equals 2,000 pounds per 43,560 feet equals 0.05 pounds per square foot. And how many ounces per square foot would this be? And guys, that wraps up your snow math lab. Hopefully this helps. There will be more problems like this on your test. And so try to work these problems out on your own, and I'll see you in the next lecture. Thank you.